Okay, I spent some time looking at that problem that I was struggling with this morning in class, and the more I looked at it, the more I realized that it really just does not make a lot of sense, that problem. I looked at how the book wants you to solve it, and it just doesn't make any. It seems contradictory to a whole bunch of things that we've been talking about. So I'm taking it out of the exam. Goodbye for that problem. You can learn how to solve it, but I can't really tell you what the solution means in the real world. So it's coming out. And instead, I wanted to show you how to solve another type of kind of a tricky problem. This is a probability problem. It's a normal curve type of a problem, but it has a little bit of a wrinkle to it. And there is a problem just like it on the exam, so I'd like you to learn how to solve it. So let's say that you are the physician in charge of an emergency room. The emergency room is in a hospital that serves a community of, oops, let me do that in a better color. It serves a community of 600,000 people. In this community of 600,000 people, this is big N, by the way, for the population value. In this community of 600,000 people, 4% have asthma. 4% have asthma. All right? On a given night, your emergency room sees a sample. It is a sample. You're not drawing a sample, but it sees a small part of this 600,000 people. Let's assume there's that people come in pretty much at random. Let's assume it has all the characteristics of a sample. Your emergency room sees 350 people. All right. You've just discovered, oh my goodness, that you only have 20 asthma kits left in your inventory of asthma kits. You're going to get a new delivery of asthma kits tomorrow, but tonight you only have 20 kits. Will you have enough kits to serve the population, that the number of people walking in that evening with asthma? All right. So on a typical night, assuming that the sample is representative, which we assume that it is, on a typical night, you're going to see 4%. Let me write it the right way here. You're going to see 4% of this 350 people are going to come in with asthma. So let's take 4% times 350, and we are going to get, sorry, let me whip out my calculator and do that. I know I did it already, but I forgot what it is. There we go. On a typical night, you're going to see 14 people with asthma. On a typical night, you're going to see 14 people with asthma. Right? Some nights you'll see more, some nights you'll see less. If tonight is a typical night, and I told you at the beginning that you have 20 asthma treatment kits available. Oops, treatment kits in stock. Chances are pretty good you're going to be okay, right? Chances are pretty good. On a typical night, you need 14. You've got 20, so you got 6 left over. No big deal. But you're the nervous type, and you want to find out really what is the probability that I'm going to run out of asthma kits. All right, what is the probability that I'm going to run out of asthma kits? If the probability is high enough, you might want to, I don't know, send one of your staff people out to the warehouse to pick up more asthma kits. If the probability is relatively low, then you'll keep your fingers crossed and wait till the next day to get your asthma kits. So how do we solve this problem? Well, the first thing, of course, that we need is we need to get the standard deviation of this distribution. And the standard deviation, as you know, S equals times 1 minus that probability over the sample size. square root of that big thing there. And in this case, that is going to be S equals the probability that you're going to see those asthma patients, times 1 minus 0.04 divided by 350. That's how large the sample is. And the square root of that. And if you do that little bit of calculation, you're going to come out with, where's my number? I'm going to come out with I hope I wrote the right one down here. Oops, let me check. Let me check and make sure, because I wrote it down someplace. That is going to yield 101,474. We could do that if you really want to. Why don't we give it a try? 0.04 times 1 minus 0.04 is 0.96, right? Divided by 350, square root. And I can do this because I've got my tablet. So let me pull out the calculator, and I did this in Excel, so I know that the answer is right, but let's just double check. Right, this top part becomes 0.0384. Bottom part becomes still 350. And let's divide that by 350. Okay, and we're going to get a really silly number. Oops, put the square root up there. Don't forget that. We're going to get kind of a silly number, 0.00010971 according to my calculator. And let's put a square root in front of that. Where's that square root function? Oh, goody, we get the right answer. The square root of that is equal to, well, okay, so far we're looking very good. We have, it would seem, most of what we need to solve this problem. We just have to, we have our standard deviation. We have our population. Proportion, which is 4% over here. We just need to whip out our handy dandy calculator, which I'll do by showing you a screenshot of it that I transferred in over my phone. So we have this 4% that is over there, and we have this standard deviation, and that comes from over there. We want to figure out the probability that we're going to run out of asthma kits. We want to figure out the probability that we're going to run out of asthma kits. So you think, let's put a 20 in over here, hit enter, and that'll solve the problem. Well, actually, it won't solve the problem. And let me tell you why. The reason it won't solve the problem is because the problem is set up, this 0.04 is set up as a proportion. Okay? So we need to put a proportion in here also. The proportion that we have in this area over here is we have 14 over, we did it the other way around, but that equals 0.04. All right, that equals 0.04. On a typical night, we're going to see 14 people, or about 4% of our 350 that walk in is what we're going to see. So we only have 20 asthma kits. We're only able to see 20 people. The 21st person is out of luck. So the proportion that we want here, we want to find out what is the probability that the proportion we see is going to be 20 over 350. We only have 20 kits, so we could see you do this little bit of math, it's 0.471. This fraction here is equal to this in decimal. So what you would enter over here is 0.0471. And when you run that, which I did using another program that you're welcome to use if you like, there's our standard deviation, 0.01047. There is our mean, 0.04. There's our population proportion, 0.04. We're looking for the proportion above 500, above 0.0571. Okay, what is the probability? And this is because this number here, this number over here is that 20 over 350, right? And this 20 is number of asthma kits that we have available, okay? So when it does this computation, the number it comes up with is hidden down there. I don't know why they do it this way, but there is a 5% chance that we will run out of asthma kits. We have 20. There's a 5% chance that we're going to run out of asthma kits. So there is a 95% chance that we're not going to run out of asthma kits. That's all this green area over here. All right? So that's how you solve the problem. Again, the tricky thing about this problem is that you need to know what number to put over here. You need to know what number to put over here. And if you put in 20, you're going to get the problem wrong. In a problem like this, you have to put in the proportion, this number over here. And we can, why? Because we're using a proportion over here. All right, that's the reason why. Okay.